Hey everyone, let's take a look at number 3 in section 10.6. We're going to find the interval of convergence of actually three series. They start with this one, then ask you to do slightly modified power series, very similar to this one, to sort of show you how those slight changes can affect the interval of convergence. Okay, so note that the power series is centered about x equals 0. Further note, if we look at the terms we're adding up, the a sub n's, so I think it's easy to think of 3x to the n as really 3 to the n times x to the n, right? Property of exponents. And so when I look at values of x not equal to 0 for which this power series converge, I'm going to use the ratio test. So I'm going to look at the limit as n goes to infinity of the ratio of the terms a sub n plus 1 to a sub n. And so a sub n plus 1 is this, just replace n with n plus 1. And then I'm dividing by a sub n, so I'm going to multiply by the reciprocal. So just take the reciprocal of that. And then I can simplify, right? 3 to the n plus 1 is 3 to the n times 3. X to the n plus 1 is x to the n times x, and so on, so that I can do some simplifying, right? The 10 to the n's cancel, the 3 to the n's, and the x to the n's. And I just have the absolute value of 3 times the absolute value of x. Of course, the absolute value of 3 is 3, and the absolute value of 10 is 10. Now, this absolute value of x is essentially a constant with respect to n. So for a fixed value of x, the value as n goes to infinity will not change. So I can sort of pull that out as a constant multiple. And then what's the limit as n goes to infinity of 3/10? Well, it's obviously 3/10. And so I get the limit to be 3/10 times the absolute value of x. Now, ratio test says that this power series up here that we're looking at will be absolutely convergent if this limit is what? Less than 1, right? So it's kind of like the geometric series in a way out for large value of n, where the value of r is less than 1. So in this case, what do we say? Well, if 3/10 times the absolute value of x is less than 1, if I multiply by 10 thirds, I get the absolute value of x is less than 10 thirds, which means x is between negative 10 thirds and 10 thirds. So the power series is absolutely convergent for all these values of x between negative 10 thirds and 10 thirds. However, what's happening right at the endpoints? Well, we need to check, because in that case, this limit is equal to 1, and so the ratio test is inconclusive. Well, let's take a look. When I plug in 10 thirds into the original power series, notice what happens if I replace x with 10 thirds. 3 times 10 thirds is 10. I'll get 10 to the n divided by 10 to the n, which is just 1 for any value of n. And so what's this series? 1 plus 1 plus 1 plus 1 plus 1 plus 1. Clearly that diverges. You can certainly see the a sub n is 1. Take the limit as n goes to infinity of 1, you get 1, which is not 0, and so it diverges by the nth term test. Well, if we plug in negative 10 thirds, I will get 3 times negative 10 thirds is negative 10 to the n over 10 to the n, and negative 10 to the n can be written as negative 1 to the n times 10 to the n. So that simplifies down to just negative 1 to the n. And the limit as n goes to infinity of negative 1 to the n does not exist, right? That sequence is bouncing between negative 1 and positive 1 forever. And so that series here also diverges by the nth term test. So both endpoints, the series is divergent. So in our interval of convergence, we're not going to include that. So make sure you read the parenthetical note about how to enter things. They want you to use interval notation, so we have to use parentheses to not include those endpoints. Now, real quick, we'll look at the other two situations. The next one is a slight modification of the one we just did. You can see we just have an extra n in the denominator here. So again, I'm going to take the limit as n goes to infinity. Look at this expression here. Replace n with n plus 1. Sorry, that's n plus 1 in there. And simplify, right? So again, the 3 to the n plus 1, 3 to the n, I can divide top and bottom by 3 to the n. I'm just left with 3 there. Divide by x to the n, I'll be left with an x there. And divide top and bottom by 10 to the n, I'll be left with a 10 down there. So I'll have 3x times n And of course, the absolute value of that would be 3 times the absolute value of x times n. And then bottom, I'll have n plus 1 times 10, which the absolute value of that is just 10 times n plus 1. Again, this absolute value of x can come out as a constant multiple, and we're left with the limit as n goes to infinity of this. So I hope right away everyone knows that this limit is 3/10. If not, you can see the form of the limit is infinity over infinity, and you can use L'Hopital's rule once. Or you can use the technique, right, of dividing by the highest degree power of n in the denominator, which in this case is n, and simplify, and you can find that limit is 3/10. So the limit becomes 3/10 times the absolute value of x. And again, that limit must be less than 1. And we basically get the same thing we got before, right? Which is that x is absolutely convergent, or the power series rather is absolutely convergent for values of x between -10/3 and 10/3. However, check the endpoints again. It's not necessarily the same as the last one because, well, when x is 10/3, that is the case. If I plug in 10/3, this will become 10 to the n. 10 to the n divided by 10 to the n is 1. I'm just left with 1 over n. Well, hopefully recognize that power series. It's the harmonic series. It's divergent, or it's a p series with p equal to 1. However, at -10/3, when I plug in there, I'll get -1 to the n times 10 to the n. The 10 to the n's cancel, and I have -1 to the n over n. Well, this is an alternating series, and by the alternating series test, this series will be convergent, right? The a sub n's in this case would be, the absolute value would be 1 over n. As n goes to infinity, that's going to 0, and a sub n plus 1 is less than or equal to a sub n for all n. So convergence at this endpoint, right, makes our interval of convergence this, right? We include that endpoint. The last power series we look at, notice they, instead of n, we were dividing by n here. Now we're dividing by n squared. It's going to look very similar. Here I replace n with n plus 1. Got n plus 1 quantity squared down here. I'm going to simplify. So again, divide top and bottom by 3 to the n. Leaves a 3 up top. Divide top and bottom by x to the n. Leaves an x up top. And divide top and bottom by 10 to the n. Leaves a 10 down here. So I got 3 absolute value of x times n squared. The absolute value of x can come out as a constant multiple. I'm left with 3n squared up top. And then 10 times the quantity n plus 1 squared. Take the absolute value is just that. Now this limit here is also 3/10. And you can see that by, again, applying L'Hopital's rule a couple times, or divide top and bottom by n squared if you expand n plus 1 squared out and simplify. So again, if you're having trouble with that, please talk to me about that. But hopefully by now you understand that that limit is 3/10. So the bottom line is it's the same as what we've got before. This limit has to be less than 1, and that yields this interval, right? Anything between -10/3 and 10/3 were convergent, absolutely convergent. So now let's check the endpoints. Well, if I plug in 10/3 this time to this series here, I'll get 10 to the n here. 3 times 10/3 is 10. So I get 10 to the n divided by 10 to the n. I get 1 over n squared. Well, this series, 1 over n squared, that's a convergent p series, right? P is equal to 2. If p is greater than 1, then it's convergent. And when I plug in -10/3, I'll get -1 to the n over n squared. Well, that's converges by the alternating series test. And so now we have convergence at both endpoints. So you can see by slight changes, we can change whether we have convergence at one of the endpoints in each of these 3 different power series. Okay, I hope this is helpful in explaining what's going on here.